In this video, we're going to look at how to solve questions calculating moment of inertia when we're given the dimensions of the disk and also the density of the material that it's made of. And in doing so, we'll be looking at question 2 from tutorial 3 from page 8 of the LO3 course notes. Let's start off with some information about all cylinders, which of course will apply to disks. The volume of a cylinder, and we'll sketch a simple cylinder here. The volume of a simple cylinder is given by this formula here. Volume is equal to pi times r squared, and r here is the radius of the circular end of the cylinder. That's given by r multiplied by the height of the cylinder. In this case, this is our height here. So if we're given the radius and height of any cylinder, we can calculate its volume. Well, the exact same principle applies when we're thinking of a disk. Now, all a disk is a very short cylinder. We're often thinking about flywheels, so we can imagine our disk like this. Up on its side. And that's perhaps not the greatest drawing. There we have a disk. But again, it has radius here. And it has, well, we will normally call this thickness in our questions, but effectively it has a height as well. It's got some other dimension that we can multiply by here. So when we think about a disk in one of our questions, we can use this formula with our thickness in place of the height and work out the volume of the cylinder. So let's take this question 2 from tutorial 3, and we'll do the first part of it where we will need to find the volume of this particular disk. So here's what question 2 says. Question 2, find the MI, the moment of inertia, of a 20mm thick steel solid uniform disk of radius 50 centimeters. So we'll deal with everything else in a second, but let's start off by finding the volume, because in a problem like this, the first thing we need to do is find the volume. So we'll look at our formula. Volume is equal to pi times the radius squared. Well, our radius, let's write it out here, our radius is 50 centimeters, but of course we're going to work in meters through that as a standard unit of length, so it's going to be 0.5 meters times 0.5 squared times the height, or in this case the thickness. Now our thickness, we'll demark it with h, so it's keeping with our form, but our thickness is 20 millimeters. Now we have to change that to meters. So to convert from millimeters to meters, we can move across 3 zeros onto the right of the decimal place point, and we need to put in our calculators 20 divided by 1,000 to make sure that we're getting the right answer here. And moving that across, we get 0.02 meters. So we put that into our formula as well, 0.02. And entering all of this, we get 0.02 times 0.05. So start from the left-hand side, pi times 0.5 squared times 0.02 is equal to, and we'll write out our answer in a few decimal places here, 0.0157, and then it goes on quite a bit. But if we wanted to keep it simple, we can leave it here, 0.0157, that's the 3 significant figures. And of course our units are meters cubed, because we're working in meters for both the radius and the height there. And because it's an earlier stage in the question, if you're calculating this problem and feel you might want to store the calculator value and use it later on in the question, we will settle with this level of accuracy for now. The next thing we need to know about in a question like this, because if we remember, we're trying to work out the moment of inertia, and that's a formula that depends on the mass and the radius of the disk. Now we don't have either, we have the radius of the mass yet, but we have been given the density in the question, and this is where the second thing we need to remember comes in. The density of any object is given by this formula here. Density, which is represented by the Greek letter rho, is equal to mass divided by volume. Now here are some things that we know. We have been told the density in the question. It's a steel disc, so its density is given there. And we've just calculated the volume. So putting these values into this formula, density is 7850, equal to mass divided by what our volume is 0.0157, we can calculate the mass of this disk is 123, let's keep it 245 kilograms. Now, if you've been using the exact calculator value for your volume, you'll have a slightly different answer here. But again, this is only an intermediate answer in our working anyway. It's not our final answer, which will be the moment of inertia. And so now we have the mass, and this is the thing what we're looking for. The two steps we've covered here, finding the volume and using that volume with the density to find the mass. That's what we need to tackle a question like this. If we then go on to use our equation for moment of inertia, specifically for a solid uniform disk, this is not for every moment of inertia, but certainly for this type of disk, it's mass times radius squared divided by 2. And we now have all the information to complete this. The mass put in here, the radius correctly converted that into meters, it's 0.5 meters, so we'll square that and divide by 2. And we can quite happily round our answer now to get the final answer here, because this is where we're going to end the question. And we're rounding it to 2 decimal places, as the course notice does. We have 15.41 kilogram meter squared is the answer. So in a question like this, in which you're given the density of the material and you're given the thickness of the disk, this is the clue that you need to calculate, first of all, the volume of the disk, and then use that volume with the density in this second formula here to calculate this mass, and then it's back to our standard approach for calculating moment of inertia for a solid uniform disk when we know its mass and its radius. And that completes question 2 from tutorial 3 on the course notes, page 8.